The humble object pattern is a design pattern in software engineering that helps to separate the parts of a system that are difficult to test from those that are easier to test. It was originally identified as a way to help unit testers to separate the behaviors that are hard to test from behaviors that are easy to test. So, the idea behind this pattern is very simple. It says that it split the hard to test object into two modules or classes, put all testable behavior in one, and left all hard to test behavior in the original object, making it humble. The pattern is intended to improve testability of a system, and the goal is to identify the parts of the system that are difficult to test, such as user interfaces, database access codes, or other external dependencies, and to isolate them from the core business logic. This can be achieved by creating a wrapper or adapter around the difficult to test component so that it can be replaced with a simpler, more testable component during the testing. By isolating the difficult to test components in this way, the code business logic can be tested more easily and thoroughly without being dependent on external factors that may be difficult to control or reproduce in the testing environment. And this makes it easier to write automated tests that can be run quickly and reliably, which can help to reduce the risk of bugs and errors in the system. For example, the GUIs, the graphical user interfaces, are hard to test unit for testers because sometimes it is very difficult to write tests that can catch the screen behavior and movements and then can check whether appropriate elements are displayed there or not. Some platforms provide no hooks to allow us to run automated tests against the UI controls, and those that provide a way often make it a complex process. But at the same time, most part of the user interface is easy to test. So using the humble object pattern, we can separate these two kinds of behaviors into two different classes called presenters and views. And there comes the idea of presenters and views. In the context of humble object pattern, presenters and views are the two components that work together to separate the core business logic of a system from the user interface or other external dependencies. The presenter is responsible for handling the business logic of the system and for preparing the data to be displayed or acted upon by the user interface. So we can say that presenter act as an intermediary between the core business logic and the user interface and is responsible for translating the data into a format that can be understood by the view. The view, on the other hand, is responsible for rendering the data provided by the presenter and for handling user input and other interactions with the user interface. The view is typically a lightweight component that is focused on displaying data and handling user input and does not contain any significant business logic. So we can say the view is the humble object that is hard to test. The code in this object is kept as simple as possible. It moves data into the GUI but does not process that data. The presenter is the testable object. Its job is to accept the data from the application and format it for presentation so that the view can simply move it to the screen. In the humble object pattern, presenters and views work together to isolate the core business logic from the user interface by defining a clear boundary between the two components. This allows the business logic to be tested independently of the user interface, which can be difficult to test due to its complex interactions with the user. By separating the presenter and view in this way, the system becomes more modular and flexible and can be easily adapted to changes in the user interface or other external dependencies. Additionally, the separation of concerns between the presenter and view makes it easier to maintain and update the system over time, as changes to one component are less likely to affect the other. And remember, at each architectural boundary, you are going to find a point where this pattern is useful because communication across the boundaries will almost always have some kind of simple data structure, and boundary will often divide something that is hard to test and something that is easy. The more you will use this pattern, the more testability of your system will increases.